First risk assessment, gloves. So why do we need to wear gloves when we are handling radioactive sources? Even though we know that gamma is actually going to go for this. Gamma penetrates through plastic, clearly. So why? Can you think about it? Well, the reason for that is we are not reducing irradiation here, we're actually preventing contamination. So wearing gloves, very, very important. Number two, we've got our hazard symbol. So if you're in the classroom, you know about the risk assessment, you've gone over it with your teacher and you've researched about it. What about people who walk in a corridor and they're about to walk into the room? So the hazard symbol on the door lets people know that we are handling radioactive sources here, so they could be exposed to radiation. Number three, the logbook. So every time that the radioactive sources are taken out from their storage, they need to be logged and they have to be signed. And these are one of the highest thing that is checked in the school and even the fire brigade. Third thing is long tweezers. So to be safe when you're working with radioactive material and the radiation, the two big factors that we actually consider: space and time, exposure time and distance. So ever wondered when you go to the dentist and they are doing x-rays, the dentist actually just step out of the room. And that is because they're doing x-rays almost every day. So exposure time for them is great. So when we handle radioactive sources, we want to increase the distance by using long tweezers. And when I do the demonstration in class, I make sure that my students are around 2 meters away. Increasing distance, intensity of radiation decreases, which is what your practical is. Okay, so here's another thing. All radioactive sources have to be labeled with a specific code, carrying container, right? We've got a little handle here, and a lot of students think that the radioactive source is quite big. It's not, but we use that just for transporting the radioactive sources in and out from the storage. And this one is an old makeup box. And what we like about this is it's got a tiny little mirror, and when you want to look at the radioactive source, you don't want to point that towards you, you want to point it away. So how do you look? The mirror helps. And I'm going to try and show that to you in a few minutes. When I hold my radioactive source and I point it away, but I can still see if it's the source, what state it is in. So when you open this box, right, we're very privileged in our school to have two types of radioactive sources. So we've got the very, very old radioactive sources, which are kept in these boxes. These are called your cup sources, and the new ones, which are called the isotrack. So the isotrack sources are handheld sources, which means you can literally hold it with your hand and point it away. And they're radioactive sources here. So after I've shown this to you, I don't want that to be too close to me, and I'm going to move it away as much as I can. The other one that we've got is the old cup sources, right? And again, this is a wooden box. So how does a wooden box have radiation, especially if it's gamma? It doesn't, right? So what you need is lead line containers. So there you go. This tiny little box that I'm going to take out, a container I'm going to take out here, is actually made of lead. And I want to show that to you. So this is your lead line box, okay? And that's the cover for it. The wooden box is just for holding that in place. So whenever you're doing a practical, you want to point that away from the students or from yourself. And I'm going to put this lead line container in there, and this is your cup source. And again, when you're holding it, trying to be away from it, and you pick your source like that and you're pointing that away. So that's the cup source. And because I don't want, if I want to check the state of it and I can't look directly at it, that's why I've got the mirror in here. So if I want to check what it looks like, I could just point it to it and I could look at the reflection to know, I don't know what state it is in. And when we're not doing a practical, we'll put it facing down on, not on the table, on the lead line box. Okay? So I'm going to put this back. Again, reducing exposure time and further away in terms of increasing distance. So that's the risk assessment done. We're going to go on to methods of detection next. Thank you.